A single severe thunderstorm unleashes more energy than an atomic bomb, dramatically shaping our planet. These immense forces constantly rearrange Earth's atmosphere, creating the weather patterns we experience daily. From gentle breezes to devastating hurricanes, all stem from a few fundamental atmospheric principles. Understanding these powerful, invisible forces unlocks the secrets behind Earth's dynamic climate system. Weather patterns are predictable movements of air, moisture, and temperature across Earth's surface. They represent the planet's ongoing effort to balance energy, distributing heat from the equator to the poles. Without these intricate systems, our world would experience extreme, uninhabitable temperature variations constantly. These global patterns dictate everything from farming seasons to ocean currents and even human migration. The air we breathe, the rain nourishing crops, and winds driving ships are all part of this grand atmospheric dance. They are not random events, but rather interconnected phenomena driven by universal physical laws.
Scientists meticulously study these vast systems to predict future conditions and understand long-term climate shifts.
Imagine Earth as a giant engine, constantly working to redistribute heat and moisture across its surface. Scientists this engine meticulously study these vast complex systems to predict future interactions between conditions and solar radiation, Earth's rotation, and atmospheric composition. Every cloud formation, every gust of wind, tells a story about these powerful, underlying atmospheric mechanisms. Knowing these fundamental forces helps us appreciate the delicate balance, sustaining life on our vibrant planet. The primary driver of all weather patterns is uneven heating from the sun across Earth's curved surface. Equatorial regions receive direct sunlight, warming the land and oceans more intensely than the poles. This temperature difference creates variations in air pressure, a fundamental force in atmospheric dynamics. Warm air becomes less dense and rises, forming areas of low pressure, often associated with stormy conditions. Conversely, cold air is denser and sinks, creating high-pressure zones that typically bring clear, stable weather. But that's just the beginning of its power. Air always seeks to move from high pressure to low pressure. This movement of air is what we perceive as wind, ranging from gentle breezes to powerful gales. As air masses move, Earth's rotation introduces a fascinating deflection force called the Coriolis effect. This invisible force causes moving air and water to curve, shaping global wind patterns and ocean currents. In the northern hemisphere, winds deflect to the right. In the southern hemisphere, they curve to the left. This deflection creates vast global circulation cells like the Hadley, Ferrel, and polar cells. These cells dictate the locations of major deserts, rainforests, and prevailing wind directions across continents. These persistent global wind patterns, known as prevailing winds, impact climate zones worldwide. They transport heat and moisture, influencing vegetation types and natural ecosystems across vast distances. Wait until you see how these forces combine to form Earth's critical jet streams, high-altitude rivers of air. Jet streams form at the boundaries between these circulation cells, moving rapidly at thousands of feet. They act like atmospheric highways, steering weather systems and influencing daily forecasts significantly. The water cycle also plays a pivotal role, transferring immense amounts of energy throughout the atmosphere. Water evaporates from oceans and land, rising into the atmosphere as invisible water vapor. As this vapor cools and rises, it condenses into tiny droplets or ice crystals, forming clouds. These clouds then release their moisture as precipitation, rain, snow, or hail, returning water to the surface. And this invisible force shapes entire continents by distributing essential freshwater resources unevenly. Different air masses, characterized by temperature and humidity, continuously collide and interact. A cold front occurs when a dense, cold air mass pushes underneath a warmer, lighter air mass. This often leads to sudden, intense storms and temperature drops as the warm air is forced upwards. Conversely, a warm front forms when a warm air mass gently glides over a cooler, stationary air mass. Warm fronts typically bring widespread, lighter precipitation over extended periods before temperatures rise. The interaction of these fronts, along with pressure systems, creates the dynamic, ever-changing weather we observe. Understanding weather patterns is paramount for human society, influencing countless aspects of our lives. Farmers rely on predictable seasonal rains for irrigation and planting cycles, ensuring global food security. Mariners use wind and current patterns for efficient navigation, saving fuel and travel time across oceans. Aviation depends heavily on accurate weather forecasts to ensure safe flights and avoid dangerous storm systems. Major weather events, like hurricanes and blizzards, demonstrate the destructive power of these natural forces. Coastal communities face threats from storm surges and intense rainfall, causing widespread flooding and damage. Droughts devastate agricultural regions, leading to food shortages and severe economic hardship for millions.
Conversely, excessive rainfall can trigger flash floods and landslides, altering landscapes dramatically and suddenly.
Predicting these extreme events allows communities to prepare, evacuate, and minimize potential loss of life. Satellite technology and advanced computer models have revolutionized forecasting capabilities globally. Scientists continuously refine these models, improving accuracy and extending the range of reliable predictions. This ongoing research helps us adapt to changing conditions and build more resilient infrastructure. Ultimately, these weather patterns shape Earth's diverse ecosystems, from arid deserts to lush rainforests. Our planet's intricate weather system truly represents a breathtaking display of nature's constant, powerful rhythm. Weather patterns are a complex ballet of solar energy, Earth's rotation, and the constant movement of air and water. They are vital for sustaining life, distributing resources, and maintaining Earth's delicate atmospheric balance. Appreciating these magnificent forces deepens our understanding of the planet we all call home. If you found this fascinating, subscribe for more incredible stories about our amazing world. Also, let me know in the comments what weather phenomenon you find most intriguing.